is Lubna Haque. I am a chemistry professor at College of DuPage, and I'm also helping with the STEM demos as well as advisor for the Chemistry Bonding Club. Well, first of all, you can see I'm wearing gloves. Even though these are household chemicals, it's always a good strategy to have gloves on. And when younger children are working with this, we need to remind them to have goggles on because vinegar, as you know, is acidic and it could hurt our eyes. It is also a good idea to remember not to break open any of the glow sticks because those chemicals are dangerous for us, right? So just use them and then dispose of them properly. As for the slime, borax can be an irritant to our skin. So wearing gloves when you're working with the slime is always a great idea. Okay? Always remember to have your parents next to you. If you're working alone, make sure they understand what the precautions are. So we're gonna start with glow sticks. They are always concerned about glow sticks, like how are they reacting? What is the sample in there? So if you see in the glow sticks, you will actually be able to see a small glass tube inside the plastic tube. So the idea is there are two different chemicals. Usually there's an activator inside the glass tube. Hydrogen peroxide is usually the common activator. And outside you have a dye and another chemical that this activator reacts with. So when you break it, you actually can hear the glass breaking. And the moment you break it, you have it glowing. So this is the process called chemiluminescence. So it's a chemical reaction that gives off energy as light, but not so much as heat. And the other interesting part of these glow sticks is that if the temperature is higher, so if we're talking about summer months, then you're going to have a brighter glow because the reaction is faster at higher temperatures. And if you put it in a colder environment, then the reaction is slower. So lesser glow, but it continues for a longer time. The next question that sometimes people have in their mind is, how does the slime work? What is the chemistry or science behind slime? So I've taken regular glue and I'm telling you that this is where we have the base of the polymer that we can make. So the idea behind this is that there are long chain molecules that can be combined or connected with a sample. And in our case, for slime, it is borax. Borax is used as a laundry detergent enhancer. You can make a very dilute solution of borax, as I have done. So we have a little bit of glue here, and I'm going to put any food coloring. Sometimes if you want a slimier sample, you can add water to the glue, and that will give you a more looser sample. If you put more borax, you are going to get something that is harder, like bouncy balls. Once you put in the color, any color of your choice, you can then start adding the borax solution that I have made already. Usually a cup of water and a warm water with about a teaspoon of borax works well for a slimier sample, okay? When you agitate it, this is where the polymerization is taking place. So this is where the connectiveness of borax comes in with the glue systems, okay? So you can see that the slime has already formed. And as I said, if you want a slimier sample, you can add water to it water to the glue before you add the borax. So it will give you more of a slimier, ooey gooey sample, okay? I'm going to take off my gloves and show you if you use higher amount of borax, you can also have a thicker sample. So this is where we formed a thicker sample, and this is more like a bouncy ball. You can actually bounce it, and this is a harder sample, and you can bounce it and have fun with it. So this is the experiment we are going to do, which is the oozing pumpkin. So I have here some baking soda and any food color that you like with some soap, okay? About 1 tablespoon of baking soda to about 1 teaspoon of soap and a few drops of food color works perfectly. You mix all of this to make a slurry, and then you're going to place it inside your cut up pumpkin. Now, what I have done is I have cut up the pumpkin in the front, and I also have this cut in the back. This one, please make sure that you're not throwing away the piece, because we need that piece to plug so that when the reaction starts, we would have enough pressure built in for it to ooze out. Once you have this set up, you're going to pour a little bit of vinegar. Now, the amount of vinegar that you're going to pour is going to decide exactly how much of a reaction we're going to have, okay? So if you're really excited about it, you can put a lot more in the same, go, or you can put it slowly and see how much you need, okay? So I'm going to pour a little bit. And when I see the reaction starting, I'm going to plug this and wait for it to ooze out. Okay, still very slow. Okay, so let me show you, it's still reacting, okay? And if I keep it enclosed, it will start oozing out, right? You can see the eyes now, and if you want a faster reaction, you can put more vinegar. Okay, so now you can see with this reaction, you can have our oozing pumpkin, and the more baking soda you put and the more vinegar you put, you can keep this reaction going on and on, okay? Make sure you have paper towels handy because it could be messy, as you can see. And thank you so much for watching this episode of STEM at COD.